Our steps to find the radius of convergence are going to be that we calculate L equal to the limit as n goes to infinity of the absolute value of c sub n plus 1 over c sub n. And then we set up the inequality, absolute value x minus a, times that L, and we want it to be less than 1 in order to have that convergence. We're just going to solve for values x, or absolute value x minus a less than 1 over L, or we do that negative positive thing for absolute values. And isolating x gives us a minus 1 over L on one side, a plus 1 over L on the other side. In context of the vocabulary about this type of problem, if somebody asks you for radius of convergence, you want to be reporting that 1 over L. And if somebody asks you for interval of convergence, you want to be reporting that a minus 1 over L, a plus 1 over L. And I just mentioned that because it's relevant to the problems that you work on. So we're going to go ahead and do an example now of actually implementing the ratio test. I'm going to start with the full ratio test, and then I'll kind of emphasize where these parts that actually feed into your final answer show up. So we're going to consider the series, the sum from n equal 1 to infinity of x minus 3 to the nth power divided by 2 to the n times n. And we can note that for this series, if we want to find the interval or radius of convergence, well, now they're just the interval or radius of converge. Sorry about that. But for this series, we're going to have to note, like, what are our coefficients, what is our a, in order to find that radius and interval. So for this particular sum, we can just represent it in a way that really highlights where our c and a are. Our c sub n are that 1 over 2 to the n times n, and our a is that 3. So I'll start with the ratio test, and then I'll highlight when that ratio of c's kind of pops out. So if we want to know when it's convergent, we care about the limit as n goes to infinity of the absolute value of the n plus 1th term. So just take what I was given and plug in n plus 1 divided by the nth term. So write it the way it shows up in the equation. And then when I see this ratio right here, like x to power 3 divided by x squared is x. So same thing, x to power n plus 1 divided by x to power n is just x. So since x to power 1, just x, doesn't depend on n, I can go ahead and pull it out of my limit. There's no n in this, so it's safe to ignore when I'm thinking about limits. And that leaves behind everything else, which I just want to note, this is my Cn plus 1 and this is my Cn. So I'm looking at Cn plus 1 over Cn. And then I can go ahead and take my fractions on the top and bottom and swap them to just be not fractions on the top and bottom. So dividing in the denominator means multiplying in the numerator. So I want to move that up top. And then dividing in the numerator means it is in the denominator. So I move that on bottom. And here I've got the exact same thing as before with the x's. 2 to n divided by 2 to the n plus 1 is just a half. Like 2 squared over 2 cubed is 1 over 2. So I've actually got my x minus 3 and my half. And then I just care as the limit as n goes to infinity about what happens to n over n plus 1. And then if I want to evaluate that limit, I've got, as n goes to infinity, I have infinity over infinity plus 1. That's just infinity over infinity. I don't really know what that is. So I would have to go ahead and use L'Hopital's rule. I take derivative of top, derivative of bottom. And remember, I take derivative with respect to the thing I'm taking the limit of. That's n. So on top, derivative of n with respect to n is 1. And derivative of n plus 1 with respect to n is 1 plus 0. So still 1. And now there are no more n's. So the limit is just 1 over 1, which is 1. So I'm left with that this is just absolute value x minus 3 times a half. And what I would like, in order to have convergence, is for this to be less than 1. Real quick, I want to highlight that this is the answer to this. It's the limit as n goes to infinity of absolute value Cn plus 1 over Cn. Or, using the notation from our steps, this is just that L. So if that pulling out the x minus 3 is confusing to you, you could just jump right into limit n to infinity Cn plus 1 over Cn. If you evaluated that, you would go through the exact same steps and eventually get to that 1/2 is your L. Just so you know, that's where that step kind of comes from in the ratio test definition. So now, I just have to do algebra to solve for my x's. So this is going to be true if absolute value x minus 3 is less than 2. This is my 1 over L that I talked about. So that means my radius of convergence is 2. And my interval of convergence for my a equals 3, remember, is I take 3 minus 2, so 1, and I do 3 plus 2, or 5. That's also 1 less than x less than 5. If you were actually going through and algebraically solving this, you would do that minus 2 less than x minus 3 less than 2. Add 3 to both sides. And end with something that looks like that. Both are appropriate ways to represent an interval. Just depends on how you prefer to do the problem. I'm sorry, I forgot to move the steps down, or the outline down. This whole video after the steps was that example that I promised. So in the next video, we will be done talking about convergence, and we are going to talk about how we actually manipulate series to use them in a problem.